Hello, hello, hello. Ciao, Matteo.
Ciao Luca, hello everybody and welcome back.
And today we're gonna chat about the tale of a discovery, something that it was a riddle.
We
We
love
cannot talk
riddles.
in details about what, because it regards something that we cannot really go in depth right now, but we can talk about what we found in Node Core, because
Yeah.
that's
Well, it
public.
was well, to be honest, it comes from, from something that we can talk because of one of our customers, but it's really really interesting, and it's an interesting problem. It's an interesting bug we fixed or we worked around. I don't know. It's not a bug even. Is it a bug, Luca? Would you consider it a bug?
Uh, That's a good question to pin, but let's maybe start talking briefly on how that happened. So just let's see what we can say. But basically, we were comparing performance under different type of load between PM2 clusters and VAT.
Yeah.
Right. And the initial tests that were done some time ago were completely different than what we actually came out in this recent round. And there were a few variables added to it, right? A couple of extra variables. And so we went by exclusion and by deduction on what could have been. But continue.
So, okay. So let me tell. So the fundamental story, very simple. This is a reproduction case. Okay, totally generic. So,
sorry, Theo. You also have made a repository, right?
Yeah, I have. There is a repository that you can find the link, and there is a Node Core PR that I've done with changes. They made this little change, and you can get that too. And this is a little bit of an explanation of that change, which actually is really cool and really interesting. Okay, so first of all, let's start with the what I call a paradox. Okay, let's say that you have everybody told you, well, if you need to do CPU bound work in Node.js, use worker threads. Okay, so you can use more CPUs. Okay, before doing that, we were saying, the Node people were saying, use processes. Hey, okay, spin up a new process. So somebody, reported us that this very simple case. If you do fs read file sync, okay, via a fleet of worker threads and versus a fleet of processes, okay, you would get 79,000 operations per second on workers and 146,000 operations per second on processes. And I was totally shocked, okay, by this. Totally, and absolutely shocked.
Sorry, Theo, just for everyone, probably, maybe describe where the shock come from, why you were expecting actually the opposite to happen.
No, I was not sorry. The shock was why there is a regression, okay? I was totally expecting that, reading a file is reading a file. Why the heck I get different performance while reading a file from workers and processes? Okay, and by the way, this load is literally doing the same thing over and over again, which is reading a single file. Okay, so there was literally nothing else happening. The key thing,
the same file, clearly.
The same file, yes, the same file. So this is the first point. So that was actually fun. Okay, because when you have this kind of problem, you have absolutely no clue what the problem is. Okay. And you need to go and do a very long session and debugging things. Okay. And you need to try different theories and verify different stuff and use some tools. So, first of all, everybody, of course, the first thing is, well, there has to be a bug in Node or V8 or something here. Okay, why there's a problem? There's a lock somewhere. Is there a problem here? So, didn't sound right, because each worker has its own V8 isolate, is on libuv event loop, but this is actually a fast read file sync, so I removed the event loop even, because I thought maybe the event loop was causing the problem. So I even removed the event loop. And it has its own array buffer allocator too. So each one of the threads is actually a mini Node.js. Is a mini Node.js processor. Should be no real difference whatsoever while running processes versus threads. So after we ruled out Node, we went down and found what the workers were serializing something. Okay, we were losing throughput. So we went down and looked at, what it is. What is under Node? Well, we have a few bits, few friends. We have the kernel, libc, or even the hardware for whatever reason. Okay, like it's underneath Node. So, what did you do? What do you do? Okay, when you have no clue what to do, when you have these things, you need tools. Okay, and you need ways to know what's going on. Okay. Now, why? Because otherwise you are flying blind and making theories, and you're finding a needle in a haystack. Okay, so you need tools. Okay, what is the tools for this kind of debugging, Luca? You know that.
Well, our big friend, the Flames. No. I wanted to promote more from
Flame was actually very useful, okay, and pointed out that there was a big difference in the allocator. Okay, so what it showed, Flame showed something, okay, and showed that the difference was in the allocator. So allocating a buffer was costing us more memory, more time in
threads
than in workers. So yes, actually, but why? Okay, and how do you fix that?
By the way, I have a feature request for Flame. A button that can flip it from top down to bottom up.
Okay. Well, yeah. Send a PR. You can send a PR.
I will Claude to make
you it. Get Claude to do it. Okay. So get Fable to do it. Come on, Luca.
For only 20x more token.
Yeah. A lot of burn those tokens. So what tools do you end up? Did you go for? Okay, when you have no clue. Of course, ePBF that I studied over Christmas. Okay, I came back to ePBF that I studied over Christmas. Like my Christmas teaching moment was learn ePBF. And if you have not learned ePBF, folks, you should learn ePBF. It's a great tool to have in your bag. Okay, as much as perf and other things that you need to do this kind of work. But ePBF is actually a must-have, folks.
I still miss dtrace, to be honest. The father of all this.
Yeah, I know. But ePBF is pretty solid. Okay, so what does ePBF says to us? Well,
first of all, what did you ask? What was the prompt to eBPF?
Oh, I just did a long ePBF trace of both, and then it just showed everything. Okay.
The CPU
and
trace.
To be honest, what I did, I put the two dumps in Claude, I think, or Codex, I don't know, and said, "What? Find me a difference." The machine is great at finding differences. Okay, and it found the difference, and of course, the difference is obvious. Okay, and then it was the problem was absolutely obvious at that point. You know what is the key difference between a thread and a process, Luca?
In general or in Node?
In general.
between a thread and a process is going to go down to how the kernel allocates them.
Well, a kernel and a process, okay, the key difference is that the threads share the same address space, and the process
has its own address space.
Each one has his own address space, okay? Well, the problem...
Sorry, Theo, and in that case, would have been the master process of the threads.
Sorry.
Would be the same in both cases.
Yeah.
The hierarchy between processes would be exactly the same, right?
Yeah, exactly the same. So they have the same address space, okay? Well, let me tell you what happens when you allocate a buffer, okay? If you allocate in Node right now, if you allocate a buffer that is over 4 kilobytes, okay, it needs to get some memory from the kernel, okay? It needs to get, it does a malloc, okay? So we are going to talk about malloc, which gets me very much excited, okay? So you do a malloc, okay? So you go to the kernel and says, I need some memory. Give me a memory, okay? Now, in order to get memory, okay, there is a shared data structure between every thread, okay? You know what that is? It's called mm_struct, okay? And in order to access it, okay?
The name makes sense, at least.
Of course, yes. Yes. Okay, there is mm_app_lock that you need to lock before modifying the data structure. So whenever they were allocating those buffers, okay, the various threads were competing against that memory, okay, for they were competing against memory.
So the threads, because they share the same memory space, they would actually share the same address pointers, and so they were fighting on locking within that space. Okay. Because the malloc is fixed at 4 kilobyte size, right?
Yes.
So the buffer is pre-allocated for 4 kilobyte.
Well, not necessarily. So these are two different problems, okay? There is so the difference is Node.js as an allocator, in order to mitigate some part of this problem, because getting memory from the kernel is costly, okay, as we talked about, is a syscall, okay? So you need to go down and get memory. So these normally cost any time, okay? What it happens is it goes and grab it allocates a slab of data, okay? That slab of data by default in Node is 8 kilobyte, okay? And then it's chunk it up and then when you do new buffer, you don't get new memory from malloc, okay? If it's under 4 kilobyte, which is half that size, okay? So because then you can always get blah blah blah, and then if it runs out, it allocate more. So there's always at least always 4 kilobyte of memory being around, and so now the problem is so now you have this big allocator, okay, and the allocator, it was only 4 kilobytes. So if your thing was smaller than that, okay, if it's bigger than that 4 kilobyte, when you do new buffer, you need to go and get the buffer from the kernel, creating that starvation, because you are locking the data structure. Okay, this is part of the reason why all the language, when you allocate object, they allocate heaps in chunks. Okay, they get a full heap of data from the kernel and then allocate that on that heap. The logic is the same. Okay, the key difference is when that heap is released. Okay, like the reason why Node uses a smaller size for that, okay, is because you can only release the 4 kilobyte of memory to malloc only after all of it has been cleaned up, has been released. Okay, so there is a risk of overuse of those. There is a potential risk of memory leaks, essentially, by increasing that number. But look, we have a lot of memory today. So,
but couldn't you actually do just a size off in this case? Because if in case of operations that are on files, you know the fixed size, so you know exactly what would be.
Yeah, but I need the memory. I need the memory size. I need to
Yeah,
allocate it.
But you could do size off and then malloc the size off, right?
Malloc gets it from the kernel, lock that trade data structure.
Yeah, but you would avoid it to actually chunk it in 4 kilobyte. Is there a reason?
That's what it already does. Okay?
Oh, okay.
But the problem is, so basically, it reads data in chunks from the. So what it does, the way the algorithm for fs read file sync, whatever does, is you have a large file. It takes a buffer of that file size. It does a size off of the file. It gets the size of the file, okay, if it can. It has the size of the file, and then it starts reading in chunks, filling up that big buffer. So that big buffer it already got, okay?
Okay, it's pre-allocated, basically.
It's pre-allocated.
Okay.
So that's why you get this kind of really odd performance characteristics type of thing. So it's very fun. Okay, those are very fun problems. Okay.
And what exactly was the fix then?
So the fix was literally increasing pool size. So increasing this pool size. There is a constant called buffer.pool size that you can increase in your own code too. And it was defaulted to 8 kilobyte in 2015. Okay. Look at how much memory has the memory availability has increased from 2015 to now.
Minus 300, because now to buy 128 gigabyte of RAM is going to cost you like buying a brand new car.
Thank you, AI.
Yeah. So it's very expensive.
Yes, but when doing a React server-side rendering consumes 16 meg,
that's actually one of the most absurd thing, to be honest, that is the dichotomy between, and I was thinking about it literally yesterday. I don't want to diverge too much, but I was thinking really yesterday while I was traveling and I was driving on the highway in San Francisco and I saw all these kind of like billboard. And I actually said, look, memory is costing a fortune and we are actually promoting platform to do server-side rendering. And then you look at your MacBook, is capped at 128 gigabyte. And actually the new Mac Studio, before you could reach, I don't remember, like 256 gigs or whatever, like a stupid amount of RAM. Now is actually capped, I think, in 192 or even 128.
Really? They cap it?
No, yes, because of the lack of RAM availability. It's
man,
crazy.
Yeah, I can totally understand it. I'm very happy with my 128 gig of Mac, but it's but we bought it like 2 years ago or something, so that's cool.
Yeah. Was November 2024.
Yeah, that is good. But yeah, it's super expensive right now.
Yeah, it's crazy. Like generally speaking, if you look, there are applications and in relation of this bug. We are actually consuming an immense amount of memory when there is a scarcity of memory. It's kind of like the dichotomy of the...
Look, we have that other thing we need to talk about, which is pointer compression, which is very solid. Okay, that's something that we should push again, I think, at some point. Very
yeah, I think I mean, I think in transparency, right? I think one size fits all. And we were discussing, I think you and I, this thing like a few days ago, but one size fits all never existed, should never have existed, and will never exist. Like, I think we're gonna see that with pointer compression, for example, right? And we spoke about memory versus performance, right? The
Yep.
last time. It's kind of very clear that even run times, they're becoming very specific. They should become very specific to a certain kind of like decision. Like, do you go for more memory efficiency? You go more for performance efficiency. And we are going back to generalize this. I don't know if you, I don't want to jump into philosophy, but if you look at in this all new chaos of sandboxes, we're going back to virtual machine generalization, which is kind of like, is my agent doing more CPU bound or more memory bound stuff? Then let's build a generic VM that doesn't even know what it's doing, but just is a talk for probably plenty amount of wine and and a long recording. But but what is the impact of this change still? Like, because we discovered it for...
The impact of this change is better performance overall when you get a buffer, okay? Essentially, when you read a buffer, you don't need to do a round trip to the kernel, okay? So even normal Node apps will get a little bit faster when reading a file that is under 32 kilobytes. Okay, let's imagine you're reading your nice .m file or something at startup. It will be faster, okay, because it doesn't need to go and get that data from the buffer. So from the data from the kernel. That's easy. That's as easy as that, okay? In threads, this will become even better because it's not... it removes the contention, but just bumping it up to, as we did in core, to 64, okay? It's really good. The threshold, okay, it's at about 256. Over 256, it doesn't matter anymore, okay? Because the chunk size, after which there is some kernel details on this topic, but the chunk size is 128. So you need to, that is what you want, okay?
And
because it's a limitation on glibc. So glibc has 128 kilobyte mmap. So it's fine.
And like, apart that, I think that in general, humanity should learn to always keep version updated, which is something that I hope AI will help to...
I don't think so, Luca.
Fix.
We should have a the digital discussion topic for our audience at some point, okay?
The impact of artificial neurons in updating, in keeping dependencies and...
people not updating. Like, I was chatting yesterday with one of our watchers, hello, and they were telling me that they were running Node 16 and they could not update and upgrade.
I'm wondering, when people tell me I cannot... I'm wondering if it's done at the gunpoint or if it's done by a self-inflicted will.
The problem is business. Is the business, Luca?
No. This is BS, because I'm telling you, I work in large organizations, and it's just self-inflicted pain of people not wanting to explain. They are incapable of explaining correctly and going to the right person in the organization, because when the organization gets big enough, the chain of knowledge breaks, and it's your responsibility as a senior member of any technical team to cross this chain and bring your knowledge up to the chain and not complain, not say I cannot do this.
Yeah.
This is just an excuse because I don't want to lose my beautiful warm chair in an organization, and I say, yes, sir. I'm saying, and I take responsibility for saying, because that's only the truth. So self introspection for people saying I can't. If you want, contact me and I teach you how to go to your boss and tell and explain why you should actually keep version upgraded. Because especially in insurance, healthcare, government, any places that is compliant, not upgrading is basically incapability of explaining what is the security risk up on the chain. That's the only thing. That's plain and simple. And if you remember, and I can say because time has passed, at the time in Talos, they wanted to keep Express when Express was basically freaking broken. It was a huge hole of security for the entire organization, which I don't even know if Talos now updated finally to the latest. But anyhow,
Express has started shipping CVs again, so
finally,
that was a way to not have CVs. Use Express is not emitting CVs. That was a good way.
And my point was like I was pushing for adopting Fastify, which is by far the most superior web framework for Node. And I actually went to the chief security officer. It was very simple. Say, your team, they're actually leaving open doors for external threats inside of the organization. Hey, I'm in peace with myself. I actually show the value of updating. So, and it's not only about performance, people. We need to update because there are security issues that are shipped at the speed of light. And, you know, the Node.js team has, by the way, I saw that there is, sorry, I don't want to diverge, but the Node.js team is pushing security updates with a lot of rigor and structure and commitment. So it's our responsibility also to keep updated. Or else we cannot say the system is not secure, the system is not performant. If you don't update it, don't complain. Very simple. Complain when you can actually say, I'm running the latest version. And then, you know, people make mistakes, really. There might be regression, there might be new bugs and so on. But so that's a big excuse, the one I cannot update.
So anyway, here we are.
And given that so people are updating as they should, as we discussed from this discussion, the benefits you say that in terms of performance and
it can go from nothing, okay, to you will see some improvements, okay. Especially if you're doing a lot of buffer operations, you will probably see some good improvements here, okay. Because if you will do less kernel round trip. Less kernel round trip makes your application faster. Easy as that, okay? And if you're using multi-threading, okay, you will see a lot of improvements in those same operations, which is what we wanted for. So
yeah, exactly.
This is was our use case, okay? But it's generally it benefits everybody. Okay,
that's good.
So yeah, that was I think that was a very good story that we went through. I loved when we can turn some of our learnings in some of the learnings of problems we are solving in our company and turn it back to the community. So
yeah, but this one was the FS read sync was the reproduction that we could actually see, but this is not only applicable clearly to
so there is a problem. There is an underneath problem here. Okay, so the underneath problem comes if you're using a native add-on. Okay, and if you're using a native add-on and calling malloc directly, you are in trouble, and there is no pool. Like you need to implement some sort of logic like that. Okay. Because malloc will compete. Okay.
So yeah, exactly. Our exact case was about native add-on, but the reproduction that you could find was basically applicable to FS with sync and everything. Great, Theo. So today we learn how to have fun out of things that they don't work, apparently don't work. And we learned that people should always update one small step at a time their dependencies. And it's like when in school, right? During the summer holiday, just we are in team. We were kind of like doing all our homework at the end of the summer and would complain that we had to stay home for a week. But if you do your homework, one tiny small piece every day, you're gonna enjoy the summer smiling and seeing the sun. And with this beautiful sunny remark, we see each other next week, same time, same place, and
Same
hopefully
time,
with everyone with their Node version updated.
Yeah, well, update your Node version. Oh, and there is a security release coming, so you should take your chance and update. So,
Ciao, everyone.
ciao,
Ciao, Teo.
ciao, ciao,
Ciao,
ciao.
ciao.